The final application that we are going to look at in this class is called a break-even analysis. So these are functions that you will use often in the business world. Obviously, when you're talking about business, we always want to know what is it going to cost to make something and how much money are we going to make when we sell it. That's always the idea. And the cost is not just the cost of, say, materials. Let's say that I have like a coffee cup manufacturing plant. I'm looking at my coffee cup in front of me on the table. Well, there's going to be a cost of materials to create those coffee cups, but there are also going to be fixed costs that I have to pay every month, like the rent on my facility and the overhead costs in my facility, which means things like power, electricity, water, gas, all of those sort of utilities that you have to pay for. You have payroll for your staff. So there's all sorts of costs that are associated with producing something over and above just what the cost of the materials is. So the two terms that we're going to be using is if a company produces and sells X units of some product, its revenue is the money that is generated by selling however many units of that product. Okay, so revenue is the money that you bring in. The cost is the cost of producing the units, like the overall total cost, including all of those factors that we just talked about. Okay, so the cost and the revenue functions are typically going to be linear models. And so the revenue function is going to be the price per unit sold times the number of things that you sold. So for example, if my coffee cups, if I sell them for $9 a piece, then 9x would be my revenue function. So if I sell 10 coffee cups, I make $90, 9 times 10. The cost function is going to be the sum of any fixed costs that you have. So that again is things like payroll, rent, utilities, plus the cost of what it takes to produce one unit. So, if I'm looking at my coffee cups, I've got the ceramic and the enamel paint and whatever it might take to the materials wise per unit. But then you have that fixed cost on top of that, okay? Now, these two graphs, if we look at their point of intersection, the point where they intersect, which again is the solution to that system of equations, is called the break-even point, okay? So that point represents an x coordinate that tells you the number of units that you need to sell so that the money that you bring in, the revenue, is equal to the amount going out. That means it's called break even because you're making $0 profit, but you're also not losing any money. If what I am making from selling these items is exactly equal to the cost that it was to me to produce them, then I end up dead even. Okay, so the y coordinate then is going to tell you the amount of money that is both coming in and going out at that particular moment. Okay, obviously in business, your goal is to do more than just to break even, but you can see why knowing that break even point is really important because that gives you like your target. You need to hit at least more than that to be able to make a profit. So here's an example. Technology is now promising to bring light, fast, and beautiful wheelchairs to millions of people with disabilities. A company is planning to manufacture these radically different wheelchairs. Fixed costs will be $500,000, and it will cost $400 to produce each wheelchair. Each wheelchair will be sold for $600. So part A wants us to write the cost function C of producing X wheelchairs. Now you can look back up at that formula. And again, the cost is, I was thinking cost. There we go. The cost function, C of X, is going to be equal to the sum of any fixed costs. Well, we know that the fixed costs are $500,000. And then we want to add that to the cost per item to produce times the number of items. So that would be 400x. So that's our cost function. Okay, so for example, if I produce just one wheelchair, it is going to cost me $500,400. Producing just one doesn't make a whole lot of sense because you're going to lose a lot of money there unless you sell that wheelchair for $500,000. Part B wants us to write the revenue function. So the revenue function, R of X, is going to be the amount we sell them for times the number of items. So that's going to be 600 times X. So again, if I sold just one wheelchair, I would only make $600, which doesn't even come close to covering the cost of what it took to make that one wheelchair. Okay. C then wants us to find the break-even point. The break-even point is where these two equations are equal to each other. So essentially, we want to find where does C of X equal R of X. And so this is basically the substitution method because I know what C of X is equal to, so I'm going to substitute that. And I know what R of X is equal to, so I'm going to substitute that. So the equation we end up solving is 500,000 plus 400x equals 600x. And that's a pretty easy equation to solve. We only have to do a couple of steps here. And when we solve that, we get that x is equal to 2,500. Now the y coordinate of the break-even point, we need to plug this back in. Either one of these is going to give us the y coordinate. Since they're equal, it should be the same no matter where I plug it in. So I'm going to plug it into r of x because it's a shorter equation. So I want r of 2,500. And so if we do 600 times 2,500, we get 1,500,000 or 1.5 million. So it wants us then to describe what this means. Well, what this means is that our break-even point is I need to produce 2,500 wheelchairs, which will both cost and bring in a revenue of $1.5 million. My profit there would be zero, but both the cost and the revenue are the same. And so when we interpret this here, this is how I would describe it. When 2,500 wheelchairs are sold, the cost and revenue are $1.5 million. So like we said, that doesn't make you a whole lot of profit. Well, it doesn't make you any profit, but it also doesn't lose you money. So that's definitely your goal. It's not a very lucrative business because it's not making you much money, but you also didn't lose any, which is really important. So obviously then we want to talk about profit. So the profit function is P of X, and the profit function is what you have after you produce and sell X units of a product. So clearly that has to take both revenue and cost into account. So the profit function at P of X is equal to R of X, which is your revenue, that's how much money you brought in, minus C of X, which is your cost. So anything left over after you pay your bills is what your profit will be. Okay. And then again, it's important to recognize that at the break-even point, since R of X and C of X are equal to each other, when you subtract, your profit is zero. So if we wanted to write the profit function for the previous example in the wheelchair business that we just saw, P of X is our profit function. Okay. So it is going to be the revenue, which was 600x, that was our revenue function, minus the cost function, which had two terms, so we need parentheses here. It's going to be 500,000 plus 400, x. And we can combine that down, and that gives us a profit function, P of X, which is 200 X minus 500,000. We distribute that negative there. Don't forget that. So that is our profit function. So now you can tell very quickly If we were to plug in our break-even value for X, 2,500, you get 500,000 minus 500,000, it's zero. We would need to sell more than 2,500 to make a profit. And if we sell less than 2,500, we will have a negative profit, which is equivalent to having a loss. So you're losing money at that point. Okay, so let's try an example here. I'm going to have you pause this after we talk about it and try to come up with these on your own. So a company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. They're sold at $80 per pair. So we want to write the cost function, the revenue function, figure out the break-even point, and determine the profit function. So take a moment and try that on your own. So here we go. Your cost function, 300,000 plus 30x. Your revenue function is 80x. And then when you solve by setting those equal to each other, we find that our break-even point is at x equals 6,000 and r of x, or your y value, is, oops, I forgot a zero on here. That should be 480,000. So what that means is that when 6,000 pairs of shoes are sold, the cost and the revenue are equal at $480,000. Then your profit function ends up being P of X equals 50X minus 300,000. Now, you'll notice these are the only problems so far that I did not define my variables at the beginning. And the reason for that is it was already defined for us. They told us which variables to use. If that was not part of the problem, then we would need to define it ourselves. So if they just said, write a cost function, then you would need to say, let C equal the cost, let X equal the number of pairs of running shoes. So we still always have to define our variables. The difference here is that they were already defined for us. So again, this is just a sampling of some different applications of systems of equations. There's a whole lot, but these are just some of the big ones that I thought you might encounter at some point. So that's it for systems in two variables.